Hello and welcome to another episode of Hedgehog Makes. My name is Austin, aka Zombie Hedgehog, and today we're going to be continuing work on the Micron Plus. This is a beta build from West3D. This will be a release kit once everything's finalized, and if you missed the previous episodes, I've been putting this together on stream and off stream, getting it working, and today we have a few things. Number one, it is powered up. We have all the electronics, most electronics done as much as I can. Still some wire management to do, but it's powered on, it's working. I can show you that. Also, we're gonna be potentially working on the boop mechanism, but I don't know if we're printing plastic today, but that is the goal, is to do some type of further testing. So that being said, I am live on Twitch right now, and this is a making crafting hangout. If you're watching live, feel free to chat and chat, ask any questions, but most importantly, just have a good time. And if you're watching on YouTube, make sure to hit that like button. I'll upload this after the stream is done, so you are watching a VOD currently. Hello. I'll see you in the premiere. Say hello in chat if you're watching, not live. So how's everyone doing today? We have Engineered, Da Vinci, After Dark, Buddha, Incendium, Nick, Venom, Pete, Pink, Hezliz, first time chatter for Bryce. Welcome on in, Bryce. Ozzy, Herb Monkey, Mr. Ed, everyone's here today. Wow, got a good audience to start off the stream. So I'll show you what I have. Are you recording? You're not recorded. Anything I say on stream is recorded. I don't do the whole chat recording thing because, I don't know. I've never really felt the need to. Building a new printer too? Awesome, what are you working on? Usually lurk and listen while do other things. Awesome. Awesome, well that is appreciated. Hopefully you can learn some stuff and just kind of chill. A rep Mendel, nice. Zombie Santa, yes, you're welcome. I'm working on it. All right, so this is what I have so far. Let me switch over to the Canon view. We have no AB motors, but we do have a Z. Hey, boop works. Note that this is using the wrong size carriage. I'll need to swap out to this carriage, the C carriage, or the H carriage. So you'll need an H carriage if you're going to use boop, because it has more stability, and that's what it is set up for. So yeah, that's about all it does right now, is it goes up and down, and it boops. I think one of the bolts is loose too because it's rattling, so we'll figure out which one. Oh, it's the, oh, okay, it's these preloaded nuts that are rattling. And we have a raid from Nightcore. Welcome in, Nightcore. I'm not following you. When did you start streaming? What were you working on today? What were you working on today? That's confusing. Focus is off. It should be on the tool head, probably. Here, I'll angle it for you. Whoop. There we go. Yeah, forgive me. Okay. So yeah, we can home the Z-axis on this printer. Note that again, the boop is only mounted with 2 screws. Not recommended, but hey, it works. First stream testing stuff, awesome. So you got an A1 in. How do you like that so far? Boop, just little boop right onto that plate. Boop. I love it. So yeah, I'm hoping to do some further work on this. In fact, I gotta get the AB motors. Yeah, those have to be okay. So currently in the kit, these are the V0 motors. So they have the standard JSC connection for a board, but they need an extension. So either they have to include an extension for this or a different style of connector. I'm guessing the locking connector that something like a traditional Trident or 2.4 kit has from LDO. So I'm not sure, but I'm going to use some of my spare wire just to make a short extension. Solid printer only did the benchy, but it flies like the rest. Yeah, that's what I'm guessing. I'd be interested to try out an A1 one of these days. What's the build volume on this version? Okay, so the bed itself is 180 by 180. And then the height, that is the question. So apparently, according to the designer of this printer, it's not intended to go super tall. Just because of the build volume and how it's designed, it's a replica of a 2.4, right? And a 2.4, you already lose a ton of travel versus the frame size. So that travel loss doesn't get any better, unfortunately. And it's only kind of, I would say it's a little bit amplified with this, because I think it's around 160, 165, depends. No, it's not 120, that's too small. But I think it's above 150. You should be able to get 150 clean out of this. But I'm a little concerned with this PCB right here. So the way I have it right now is not intended. I have it pointing out to the side because that's the extruder I picked. This is this board, the pancake, which we'll definitely talk a lot about. The pancake board is designed for a standard V0. So that has a vertically mounted stepper where the mounting holes are not vertical, horizontal to each other. But pretty much any aftermarket extruder, like a Sherpa Mini, this is the sail fin, etc., orbiter even, they all have their motors mounted at an angle to save space. So because of that, all of these boards that mount with the outlet like that, they'll all face kind of like that. I actually don't think that's a bad thing for this. Just because when you're moving around the printer, like if it's in this orientation, it seems like it's a pretty good, like the cable itself isn't gonna hit too much. So I don't know, I kind of like it, but I would want to mount it properly. Another thing is I think this whole thing can be lowered a lot and not mounted on here. So if we have this kind of lowered and placed down here, this whole cable chain wouldn't stick up as much. And that's kind of the limiting factor on how high we can push this right now. So let's just bring it up to 165 and I'll show you. So that's 165, and just kind of, you know, planning ahead. This is how I currently have the cable. It'll probably be worse than this when I mount it upright, but very similar. So if there's a flat top hat on here, this is going to hit the top. Now, you're not going to be printing at this max build height very often, right? I would say very rarely are you ever printing this tall, and I don't think it would be too much of an issue if this occasionally touches the top here. So I don't think that's like a super bad thing. But yeah, keep in mind that, you know, if it touches the top like this, we'll kind of want to go in a weird position, and it's not optimal to print at that height. Go Bowden. I will never go Bowden if I can help it. I don't think Bowden is a great setup. But yeah, that's the current situation. That's what we'll be rocking with for now. And of course, we'll have a Bowden tube. That's probably the main issue. Not even this flexible chain, but the Bowden tube. Because that's to come up from here and go up. So yeah, that's... I don't even know if we can print this tall, actually. I don't think so. I'm looking at getting a top hat for this, which I think would look pretty nice. So it'll be a pretty, like, just basic angled top hat that lifts it up, probably about like, oh, I don't know, this much, to add that extra space in. Put an ERCF on it, right? So that's just some tentative ideas. But for stock, you should be able to get, you know, 150 pretty easily out of it. So 180 by 180 by 150 pending, you know, I still have to finish building this thing. So yeah, that was the build volume. It's essentially a mini 2.4, which is actually kind of cool because all the bearings are small and everything's kind of compact. It's pretty cool. I really like it. So right now I'm going to be kind of just talking and making cables. So I'm just making some extension cables for these motors. Like I said, I currently don't have them, and I'm working on providing feedback for different things that, you know, just need some slight tweaks. A couple things here and there. So many builds going on. Yes, I have a lot of builds going on all the time, feels like. The V0 was recently, I'm not gonna say completed, but recently got printing. I haven't done any major prints on it yet. I'm actually working on just doing some final tuning. I have some panels coming in later, but that's been a pretty fun printer. A little bigger than I expected, to be honest, but that's not a bad thing. It's just a little bit on the tall side. Getting that top hat, right? As soon as you add a top hat onto a printer, the actual printer, you know, goes to like right there, but this top hat adds all this extra. So actually, this top hat right here is a great representation of kind of how this system would work. If I wanted to add on extra height, which I could probably go to 165. So the physical maximum that this can go to, if I push it, is probably around like 180. Undo the motors. 180 by 180 by 180, probably like maximum travel. Probably a little less than that. My drag chain isn't long enough to handle that, but you get the point. So this kind of sticks up flush with this top right here. So if I was to add a top hat like this, or that size, you can easily get some extra build volume out of it. That cable chain would have to be longer though. I am luckily using the printed chain. So it's pretty nice. It doesn't snap in as nice as the regular ones, but you can easily just print some extra chains for it. So I might do that. I don't think there's a harm of adding extra length. In fact, I've had more harm by not having enough length, honestly. But I like the look of it. And they can easily add on extra segments if you want to. All right, so I really need to get this thing wired up, so let's do that. So I'm just taking some spare wire that I have. This is just for wire silicone cable. Not recommended for long-term use in drag chains. I would actually strongly discourage it, but for a temporary solution, it'll work fine. I think this is 24 gauge. Just making some motor extension cables. So what's left to do on this build? Well, I'm waiting on a heater. That's kind of the big thing, is there's no heater right now. So if we do print on it, it'll have to be on like Kapton tape or painter's tape, etc. Or the whatever bamboo sheet. Maybe we'll just throw a bamboo sheet on there with some glue stick. But no, I'm waiting on that pad. So that'll come in when it comes in, but I can get a lot done while I'm waiting, so might as well. Let's see, so one of these has to be, I could do a lot of crimping right now. What's your favorite build this year? What was the first thing I built this year? I think I've done quite a bit, haven't I? What have I built? Was the 2.4, was that this year? Cocoa press. I did. I'm gonna say that I essentially built a cocoa press. I telecommuted in and built a cocoa press. That was a fun build. Very interesting process. let's see. If I'm gonna have motor connect, I don't think it really matters. I'm just gonna put these pins over here. My favorite build. Man, I don't really have a favorite build. Every build that I do, I learn more. So the more I do, the more fun I have as I build them. So the V0 was actually quite a fun build. I enjoyed it. I took my time, and I made it exactly what I wanted. I waited as I was building it, like, okay, I'm gonna print off this mod for it, and we're gonna, do this mod. Hold on a second. I gotta figure out which I can remember which one's the female, which one's the male. I think this one's the male. Is it? Molex. Must have one Molex connector around. Okay, so that one right there is female. I don't want to unplug while it's on. I guess I can shut it off. Just need a reference point. All right, so this one takes the male pins. Okay. Sometimes I do that. I'll just like take off a connector and inspect the way that the pins go, because I can't remember it for every single one. This one gets male pins. Omaha! Thank you for the 17 months. Keep forgetting to unsubscribe. See, any more months you can forget. Resident Toxic emoji, right? That's a good one. Thank you, Grant. My favorite build. I don't know. I like them all. Now, if I'm talking the overall best build, I think it's gonna have to be the Trident. I actually do think that my best build was the Trident. It's currently not the best printing build. I still have some tuning to do, etc. But in terms of the build itself, that was probably the most rewarding. It's in the wrong hole. Shoot. So the Trident just kind of works, right? You assemble it and everything kind of goes together. There's a lot of like aha moments with the Trident. Like, oh wow, that's how they do that? It's that simple? It's pretty nice. The 2.4 was also a ton of fun, but there was a lot of, not repetitive steps, but repetitive steps. Like you'd build 4 of each thing, and for my ADHD brain, that gets old kind of fast. I'd rather build 3 of each thing instead of 4 of each thing. So the Trident has better instant gratification, if that's what you're looking for. Didn't order enough screws? You never do. Never, ever, ever. I've actually been getting some, technically, keyboard parts in. Technically. Because I am working on a couple of printer designs right now. Just trying to figure some stuff out and just having fun with it. So I've been working on exploring the keyboard ecosystem, and it's pretty nice. Obviously, it's a really, really good printer, over-engineered, like a lot of these printers. It's gonna take me 10 years. I have to have a lot of conversations while I crimp. I was gonna do this off stream, but I actually got the boop working off stream. I had it connected to the wrong port. Cool. So we'll talk about that tool board in a minute here. But keyboard. Keyboard's pretty cool. It's not for the faint of heart. It's not something that you just want to build, kind of like an NX printer. You don't just build one. Like, I need a printer, I'm going to build this. No, you don't do that. You build it because you're an enthusiast and you want kind of the best of the best, or you want a completely different experience with building a printer. So Keyword does some pretty cool things, and kind of their signature is ball screws. Hey, Cabanas, how's it going? So this right here is a Z-axis, part of a Z-axis for a keyboard, right? So it has a ball screw. This whole part is one piece. It mounts a motor. You have a coupler in there, and you have a giant bearing that this rides on. So that mounts a 30-30 extrusion. And yes, I did edit it, so I chopped off the second 30-30 that would be there. So that's just, I'm just kind of playing with it. I've never used ball screws. That was a $15 ball screw. I want to play around with it and see kind of how it works. Kind of like, why would you go with the ball screw for a Z-axis? Is it even necessary? I like to do that a lot. I'll build something just to experience it in person. There's one thing of watching a review, but it's a whole nother thing when you get to physically hold something and, you know, turn some dials. And that's what I like to do. I like to experience things by holding it and playing around with it. That's why I love to do... I like to have different styles of printers, right? It's hard to recommend a printer when I haven't really used it and be like, I don't know how I feel about that. My engineer is showing. Right, it's kind of, it's just what I do. Thank you, Liz, for the 300 bits. I don't have alerts, so I might miss some things, but thank you, Liz, for the 300 bits. And Twitch for the 30 bits. The experience in learning is, and learning it entirely. Yeah, this 3D printing brought me a lot. It still continues to. Even though, let's face it, a lot of this stuff isn't really practical for a lot of things, like the knowledge we learn. Like, I don't need to learn about NEMA motors for really any other hobby. But it's how you think about it, right? It's the way that you have to process issues and troubleshoot things. That's where a lot of the benefits come in. And just helps you keep engaged. And it's the same reason why you played with Legos as a kid. Legos, oh my god. Lego as a kid, is that you got to experience new things and try out different ways, tinker, etc. And I think it's important as an adult to continue to do that, continue to learn, continue to tinker. And there's just not enough of that nowadays. Everything is a lot of instant gratification. You just buy something and it works, great. Call it a day. But with printers, there's a lot of ways of doing the same thing. So it's a lot of fun. You make it your own. You can change colors, change parts. You have your own style. And that's awesome. Okay, there's one part of one done. Let's do the other. Tinkering is expensive, especially Lego. Lego is stupid expensive. Crazy expensive. It's a lot of fun. I do like Lego Technic quite a bit, even as an adult. A lot of like the RC style stuff, I like that, personally. If I'm going to spend money on Lego, it's going to be Technic. And 3D printing is not cheap either, but it's one of those things where it's almost justifiable. Like Lego, okay, Lego is less justifiable, but a 3D printer, you build it, and then you have a 3D printer. You can make cool things. I'm working on a Nerf, a dart blaster that West3D sells. They have a kit, and I'll be able to 3D print the whole thing, assemble it, and I'll have a working blaster that I made using a 3D printer. That's awesome. And of course, a lot of stuff behind me is all 3D printed. Decorations is just, it's a completely different experience. Build 15-year-old designs because you think it's funny. Like really old 3D printers. Started printing Lego and end up with a full Millennium Falcon? Yes. There's some really crazy big projects you can do with 3D printing if you have the time and patience. I like smaller projects. Printers for me are about the most that I want to do as like a 3D printing project. Apparently it's difficult to print Lego. Well, yes. Lego works extremely well because it's all very, very precise injection molded. Everything has to be just perfect. And 3D printing, tolerances aren't repeatable enough printer to printer. Now, maybe something like a bamboo. So if everyone has a bamboo with all the same filament, with all the same settings, maybe you can start developing some systems that are, you know, more consistent. But if someone wants to print that same thing on a different printer, then, well, they're out of luck. Probably resin print Lego. Yes, you can resin print Lego. you can certainly do that, but why? Right? Unless it's a custom piece. I've always said that if you want to print Lego, print stuff that you can't buy, right? Print cool wheels, print cool mechanical assemblies. Like that, I could imagine if I had a 3D printer when I was working on Lego Technic as a kid, which a friend of mine went to some school. I don't know, it was like some type of trade classes when he was in school, and was actually able to use a really old 3D printer and print me a Lego gear, like a little Lego gear. And I kept that thing forever. Like, that was awesome. Just one little piece. It's like, man, can you imagine if I could just design or go online and print different Lego pieces? Especially those damn gears, you know? Just want to print a gear out. Make a custom gear ratio. I can make cool things like gearbox assemblies for cars. There's a lot more you can do when you have access to a 3D printer. Good evening, Barrett, and anyone else who might be watching live. As a reminder, if you're watching this on YouTube, this is a VOD. I am recording this, and we'll be posting this on YouTube after. So make sure to hit that like button, subscribe if you're not already, and buy some merch. I have merchandise. And if you have not tried my shirts yet, they are the softest shirts that you will ever try on, guaranteed. I guarantee it. They're actually pretty good. Everyone who's bought them are like, wow, these are actually really good. So purchasing merch goes directly, all the proceeds go directly back into the channel, so I can afford to buy parts for projects like the upcoming tap changer build, the Voron 2.4 tap changer, where this is the frame. Just a little bit bigger than the Micron. So stuff like that, and of course, just exploring new things, right? Companies are making a lot of new parts. They're pumping them out, and not everyone gets to test them. So I want to work with more companies, and if I can't, just straight up buy parts so I can test them. I plan on really diving deep in 2023 or 2024 into testing. I want to do more testing. So once I get these main set of builds done, unless I get one specifically into build, I'm going to be kind of putting a pause on printer builds and focusing more on printer parts testing, because that'll be a lot more transferable. So yes, this is the 350 LDO 2.4. And surprisingly, it's not that much bigger than the Micron. Like, it scales up, sure, but it's not that much bigger, really. That's the power of Core XY. This is a 180 and this is a 350. It's probably going to sit like this. Like that. So if you have the space for it, like, if you have this much desk space, these will take up the same amount of desk space, roughly. This one's a little bit wider. But that'll be fun. My general recommendation, I have not built a 350 2.4, but if you're going to build a 2.4, you might as well build a 350. If you're going to build a Trident, you might as well get the 300. It's the special edition 300 millimeter cube from LDO. That one increases the Z height with custom Z steppers, Z lead screws, to get a more build height, because the stock Tridents are limited to 250. Voron is crazy space efficient. It's not bad. Yeah, I think there's other designs that are like slightly better, but you're really not getting much better than this. Especially with the 2.4 style printers, those are definitely space efficient. Okay, so this is what we gotta do now. I have these pigtails in the motors. I have to cut them. I'm gonna snip them, and then I'm going to wire up the wires onto the new connector, which is an inline Molex connector. I'm going to wire them up so they're the same pinout. Fun fact, you can get extension JST XH connectors, like a fan extension cable. You can just buy those, and they come with all the right stuff necessary. Actually, I started using those to make my own extension cables, and they're really nice. So I recommend picking some of those up. I get them on Ali. I don't know where else to get them, but they have 2-pin, 3-pin. I should have got 4. That would have been perfect for... I never thought I had to extend a stepper motor, but that's the idea. Your 2.4 is 350. Didn't see a point going smaller. The general idea with the 350 versus 300 2.4, most people, I'm going to quote most, oh, I got to strip these. Most people really don't need that big build volume. And if you're printing ABS, the major downside is you'll have to wait for that entire chamber to heat up. It'll take so much longer than a smaller printer. So that's the issue. It's not really the physical movement size. It's if you're printing ABS, you gotta wait for the chamber to heat up. You wait for everything to heat soak. Yes, the printer does need to heat soak if you're printing ABS on that style of frame. For other printers like the Bamboo, I don't heat soak it, and it seems to work out fine. I don't know if it's the style of the kind of unibody chassis, but with these aluminum frame printers, you gotta let them kind of expand a little. And I didn't realize how noticeable it would be. I did some probing tests, and letting my Trident heat soak for 2 hours, the Z offset kept changing. It would slowly creep up as it expanded. It was very interesting to watch, and I'll have to do some more tests repeating that, because that's kind of crazy. Building a 250 Tridex in the spring. Yeah, so multicolor printers, I feel like those can be smaller because you're generally not printing huge things that are multicolor. That being said, designers have started to design for the Bamboo. So you'll see a lot of multicolor models. Whoops. I didn't put the wire into my... Oops. You'll see a lot of multicolor models designed for a little bit over 250. I'm printing one of those... Oh, what is that thing I'm printing? It's like a... the little, like, candy thing. Not candy thing, cake thing. I'm printing one of those on there, and it's the same size as the build plate. So, that being said, if possible, I think 300 for an MMU would make more sense. Not MMU, IDEX. I think the SVO4 is a 300 millimeter. And I don't know what you just need the build volume to be greater than 250. That's probably optimal. And again, a lot of people are designing stuff to max out the volume on a Bamboo. So you want to think a little bigger. And when you're building a printer, the cost surprisingly doesn't increase a lot by going bigger. And similarly, you don't save a lot by going smaller. That's why you don't see a, you know, like an X1 Mini, like a 180 enclosed version. There's no point. It would cost like $100 less. No one would buy it. Need a custom bed plate. How do you get first sheet for it? Well, stick with I mean, I don't know the Tridex very well, but if you can build it as a 300, I would go for that. But it depends what you want to print. If you're only printing small things, it does make more sense, again, to go with the smaller printer you can go, the better. Oh, and that part actually finished. Wow. Very convenient timing. Fill that off. Testing out this new sheet that I got. H1H bed. This guy right here. Look at that bed. That's crazy. Crazy texture. What is this called, though? What is this thing? Cookie? It's not a cookie. It's like a cake. Yeah, the bed's pretty nice. I have an affiliate link for this in my Discord if you want to check them out. They're Jupine sheets. Make sure to go through the link because it has a list of all the sizes for all your printers. You can get them up to around 300 for the fancy variants like that. So I've been using them on my 2.4. But yeah, so this is a great example. Something like this. This is it'll probably fit on a 250. Let's see. I have a 250 Trident right here. Like if you went edge to edge, yeah, something like that would fit, right? Just barely. So 250, that's a pretty good size. It's not bad. Yeah, this is the H1H. I will try to get one for the Micron if I can, but I don't know if they make that specific size. That's kind of what it looks like as the texture. Hard to see because the camera is blowing it out and stuff, but it looks really good on darker colors. That's kind of a cool effect, and that is reusable. I really like those. The best part is the cost. They don't cost that much, like 20 bucks for one of those sheets, and it's a double-sided with PEI. So cool. This was printed in Polymaker. This is all Polyterra. This is cotton white. We have a PLA, I think it's the PLA Plus red, and then one of the greens. This is a, oh, PLA Plus green. Okay. So essentially all PLA Plus colors. I like it. I want to display it now. Put it up here. It's pretty cool. It's a lid for something, but I could just have it stand alone. I'll actually have to make the jar. Nice. Yeah, Polyterra is perfect. Where I have a link in my Discord. On my Discord under the affiliate link section. I don't have the link handy on me. If you're watching on YouTube, I think I have a link down below, so check that out. I would strongly recommend just make sure that you clean them with actual dish soap. If you don't clean your bed with dish soap, guess what? Your parts won't stick. And you'll end up with kind of warped corners. And that's no fun. So wash it really good. I do use another West3D product called Maker's Mistress. It's their own bed adhesive. So I apply that on all of my fancy sheets, and that works out well. But if you have other adhesive that works well, I would strongly recommend it. It's not going to have the same good adhesion as PEI. So even glue stick, honestly, might be good. A pro tip, if you're going to use glue stick on a bed like that, water it down with isopropyl alcohol. Use a lint-free cloth. You can use a coffee filter if you have one. And just kind of spread some glue stick on your build plate, pour some isopropyl, and then scrub it in. It will thin out the glue stick, and you'll have a nice thin layer, because you don't want a thick layer of glue stick. That's not desirable. There you go, Liz. Yeah, I'll get the links in chat if you want to click into that. I seriously love them. My favorite though is the PE. Oh man, what is this one right here? It's this build surface. It's like the triangles. I can't remember if it's PEO or PEY. I always get them mixed up. This one's PEY, okay. But the PEY is probably the best because it adds a subtle texture. It's smooth and it's really cool. So it adds that like triangle look. If you're printing models to sell and it has a flat face, like seriously, look into getting one of those sheets. That could increase the value of what you're selling because it has that wow effect. Microfiber cloths for glasses. I can imagine that working well. When I first started, I got coffee filters because it was pretty cheap. I now use these blue shop towels that are hiding in the corner of my screen. I buy those in bulk. I get a 12-pack, and then I use them a lot. I use that for applying my Maker's Mistress, just cleaning off sheets. I use them as a kind of a surface for when I lubricate rails. Very, very handy to have shop towels. Wow, this is coming to like a stuff you need for printers episode, isn't it? Maybe we should do another episode on the Z and Z show. A refresher on what kind of stuff you need to 3D print and build printers. If you don't know, I have I want to call it kind of like a podcast, but it's a live show on Twitch, Monday nights, Eastern Time, 10 o'clock p.m. Me and my co-host, Liz, we talk about various topics, generally showing off makes, what we've made for the week. Liz generally makes about 20 things, and I'll make about 2 things. But it's fun. It's a lot of fun. And we both learn things from that. We'll have a link in the video description if I remember that as well. Try not to add too many links in the description because then it becomes like too long. I want you guys to actually click some of the links in there. If you want to buy anything from West3D, I do have an affiliate link. Again, that does support the channel quite a bit. West3D did send over this kit for beta testing, and they gave me permission to stream the build process. I have provided feedback, and they are improving the kit. Simple as that. But it's fun building a different style of printer. So this is the Micron Plus, which is a large version of the Micron, developed by HeartK. The coolest thing about a lot of these printers, the developers are active. They're active in the community. There's on the, shoot, what channel is it? I always forget the Discord. On the Doomcube Discord, you'll have to find that one. But there's a Micron section. And if you have questions on this build, you go right there, ask them. There you go. The Voron Discord is actually very useful too. If you have general questions about things 3D printer related, I've been extremely happy with the folks over on the Voron Discord. Everyone's been super helpful. As of recently, it's been a very, very good experience, and I spend more time on there. And I'm serialized now, finally, so I have access to all the private sections. I didn't realize all the benefits you'd get from serializing your Voron. So once you finish your Micron, serialize it as a 2.4, and get your serial, get your access. Oh my god, I can't crimp this. I can't crimp this. Won't go in the hole. Mr. Stream, where you wiped your hands all over your brand new build plate A1. Oh my god. Oh my god. Yeah, that's a pet peeve of mine. Even when you're about to clean it, like, I don't handle my PI sheets with my oily hands. Fun fact, your hands are supposed to be oily. That means you're human. So if your hands are oily, that's not bad. It's not bad. Yes, it can be annoying, but it's not bad. So just remember that your hands are oily, and touching build sheets with oily hands means your parts won't stick to it. It's very obvious when someone has a print issue and it's a thumb size or like a finger size gap where nothing's sticking. You don't think you touch it, but you do. Probably easy to get a cereal. Yes, it's way too easy to get a cereal, honestly. You build a Voron, you take a video of it, done. Post it to Reddit, and then it gets serialized. It's a legacy process, but it works. I'll get these crimped eventually. Tom did do a video on the effects of the sheets, but he forgot to clean them, so he had very, very bad adhesion. And I was a little bit disappointed because those sheets are really cool. They're extremely cool, but you have to really use them. So I'm sure once he, if he ever uses those sheets, once he realizes that he has to clean them, he's gonna have much better experience. But yeah, if you want to check out some of the effects, Tom does have a full video on them. You can kind of skip around and just see how they look. I've already shown them off, the ones I like. Yeah, he wiped them off with isopropyl alcohol. Fun fact, a lot of fun facts today. Wiping off your build sheet with isopropyl alcohol does almost nothing. It just spreads around the oils. It doesn't actually collect them. You want to use a dish soap, which is designed to remove oil. That's why you see the commercials with the ducks full of oil, because it removes the oil. And you want that. You don't want any oils on your build sheet. Especially when they're new. They come out of a factory. Factory's not clean. They just slap a protective sticker on it, ship it out to you. You need to clean them. Yeah. I mean, I'm just assuming that if you unbox something and then put on your build sheet and then take off the protective coating, wipe the alcohol, you haven't gone to the sink and washed them properly. I think that gets missed a lot, and it's just weird. Like, people don't understand the very, very, very basics of 3D printing until they run to an issue. I'm like, oh, I didn't know that. Like, did you know, on the Bamboo, you have to level your bed? Did you know that? On this printer right here, the X1, and I guess the P1, there are 3 bed leveling screws. You have to level your bed, or else the whole bed does this when it prints. So if your bed does that, you need to level it. Look it up. It's pretty easy. All right, let's see. So I run, okay, to catch up what I've been doing while I've been going over 10,000 tips, I have crimped extension cables onto these motors. They're just some cheap Molex style connectors onto the silicone. Yes, silicone. Do not use silicone wires like this in a drag chain. Big no-no. Don't do it. Don't do it. They will just break. I've had it happen. But I temporarily have put those on. They'll be fine for testing. So I'm going to connect those up. You can solder these connections together, but I don't like soldering stuff like that unless you absolutely have to. I'd rather see a physical crimp connection. So there we go. Give it a little bit of tug test. Make sure none of the wires immediately come out. Well, I guess that connector wasn't plugged in. Make sure none of the wires come right out. So good enough for testing. We'll be able to see easily if it works or not. Yes, incentive. You are correct though. These sheets do not have the best adhesion. That's why I say to use a little bit of additives. I've always said that. I can use it with PEI. I use Maker's Mistress just to add a little bit of extra, extra help. Like if you're printing something and you don't want it to peel up, you can have the best leveling in the world and just use a little bit of adhesive. just a little bit. Doesn't take that much. It really doesn't. Because I've had some pretty nasty failures on parts just because the bed wasn't clean or I didn't use any adhesive or something. Just on straight PEI. It sucks, but you learn those lessons. So right now I'm just removing these. The printed drag chains aren't ideal because they have these little latches on them and they come right off. So I'll have to, I think I'm missing a couple because they come right off. I'll have to reprint some of those. Probably make this whole thing longer while I'm at it. But I'm going to take these wires and then just route them through that drag chain. Terminal blocks. 10mm brim. Yes, put a brim on it. And for the love of God, do not use a raft. Oh my God, if I see another person using a raft. A raft. Wow. I forgot that's even an option in the slicer. Use a brim. Don't use rafts. I know, there are some use cases where you absolutely have to. And yeah. I get it. Okay, I'm gonna run these. I gotta I don't want them to get twisted, so I'm trying to keep them straight. I'm gonna try to put these through down on the bottom here. Definitely one of my least favorite things to do is wire up a printer. But this kit made it fairly easy. Because it comes with this harness. And once I get this run and crimped, we're gonna look at the tool head board. But there's a tool head board. There's two ways of doing a tool head board. Number one is a CAN or USB connected board. And then option two is a breakout board. So for example, if you buy an LDO kit, you get a breakout board. On one end, you have all of your cables that will go out to your control board, etc. They're physical cables that will connect to various places. And then on the tool head, you have a tool head board. And those are fine. In some ways, I actually prefer them to the whole CAN setup because you don't usually need a dedicated MCU and stuff on your tool head. That's not necessary. It really isn't. When you can just have physical wires, I don't think it's super necessary. It just adds a lot of complexity, extra setup. When you just want something to work, it's nice to have this straight connector. But you do have more cables with this. And then that's where people want to reduce as much as possible is the amount of cables. Like all these cables that I'm running right now through this drag chain. It's not too bad. You run them once, but you know, if you have to do any maintenance, you don't really want cables. Yes, your elder is the one trying to use wraps. Yeah, there's a lot of people who still use old techniques, which work. If it's technique and it works, use it. But there's a lot of additional slicer tweaks and stuff you can use to get better adhesion, better lots of things, better quality even, better speed. Better speed. I'm thinking about doing a video just on increasing the speed of your prints. Too many people are using the stock profiles, and I can see, actually, both ways. It goes both ways. I see too much of people printing too slow, which is fine. Slow is fine. But then people are printing too fast. I don't use the stock profile on Bamboo. It's too fast. It's way too fast. Way too aggressive. 200mm/s outer walls, when the actual hot end isn't really that high flow. It's like a standard high flow hot end. I don't know. Cooling is okay, but... and then the way that Bamboo specifically does input shaping, it's extremely aggressive. It has the equivalent of an extremely high jerk, which means it has to use very, very aggressive smoothing. And it's not the best for your print quality. So to compensate, I slow down my outer walls a little bit, and that does significantly increase the quality, at least in my experience. All right, thank you for the tier 1 sub, 4 months. Thank you very much. Happy holidays. Happy holidays. I'm using a lav mic. It's a Rode. I'm looking to upgrade to the DJI system next year. That is my goal. I think the DJI ones sound better, at least from what I can hear. And it has a 2-person mode, so I can do other things with it. If I go to an event, I can record. I am planning on going on events. I don't know if I'll end up there, but I plan at least trying to go to some of these events. I went to all of them last year, besides Smurf, and that was a lot of fun. I would totally go again. So, currently looking for ways to get there. Yeah, these printed drag chains, you have to have really good... you have to really spend a lot of time printing these well. And if you're worried at all about these, just use the included drag chain. I probably should have, honestly, but I wanted to look cool. So I went with the fun colored one. I think I have to extend this out a little. I'm not sure. I've been tweaking around with this chain, seeing where it should lie based off of the bend radius. So I've been moving it back and forth a little. We'll leave it there for now. Okay, so let's show you what I did on the camera. All right, so I don't know how well you'll be able to see it, but disconnecting drag chains. All right, is this on? Yeah, it is on. I took these cables in the back and I extended them just like that. Yeah, whatever, it's gonna focus right in the middle. And I just ran them through the drag chain. So now we have to do a little bit of cable management just to make sure that it all stays in place. Put on external walls and punch the infill. Yeah, like if you look at the slicing, I'm gonna turn this off to run some cables. If you look at your slicer, it's crazy how little time it saves to slow down your outer walls. So just do it. You're not saving much time. You're not doing yourself a favor. Slow it down. Nice and slow. Focus on quality. If you can. All my print profiles aren't perfect. I still have a lot of work to do myself, but that's part of this whole channel, is just experimenting, you know, pushing the limits. I like to kind of just try things that don't make sense to see, you know, how it reacts, how it works. Okay, I think we're pretty much at our limits here. Trying to get this drag chain, pulling it in so it doesn't have a lot of slack right there. It's all stuff that you want to do as you run the initial cables, but I'll do an overview of the wiring once it's actually complete and printing. That's that part of this build series that never exists, and I'm sorry. I'm very sorry, but it happens, right? I'll end up just not completing the wiring. So next year, I do want to make more videos on wiring and crimping and stuff. It seems like there's a lot of new users who have never crimped. Heck, I'm still not an expert at crimping. Nowhere near an expert. Right now, I'm just getting all of the lengths correct. I'm trying to find this one that's way too long so I can pull it in. Wow, it's gonna be the last one I check. This one? Yeah, there we go. Perfect. Lovely. I don't know if I want to show you the bottom of this, but I guess I can. It's very temporary, as I was just testing out everything. But this is what it looks like right now. Rat's nest, for sure. Ooh. As the chain file public, it's in the Micron files. Don't forget Super Slicer. Yeah, Super Slicer still exists. So let's see. Here is my current wiring, which needs to be managed. This is a functional wiring. Very functional. It works. It functions. So we have our UHP power supply right here, which I have to tighten up these rails. I was trying to get the right fitment. This will probably sit a little higher, but it's a little loose right now. We have the Wagos right here on this little, it's actually a DIN rail mount right here, which is cool. We have our octopus a little lower. And then there's a Raspberry Pi hidden. I don't think I have the right mount for it. I'll have to look back in the files, but Raspberry Pi goes on the bottom there. So I'll have to spend some time, once I know that it all works, then I can spend some time going through and properly cable managing it. It won't be too hard, but you know, just throwing some zip ties on and such will make a big difference. Yes, this one has electronics. No bottom panel yet, but the bottom panel does fit on pretty well. Where did I put that? It's around here somewhere. Oh, where is that bottom panel? Good question. It's huge. I can't lose it. It's impossible to lose. I did put it somewhere. Ah, whatever. It's just a big bottom panel. It's black. It screws on the bottom. You can imagine what it looks like. Yeah, lots of wires. Lots of wires. So that's the downside of the harness, is that you have this set of wires coming through that you have to connect. I actually think the harness is a lot longer than it needs to be, but that's fine. We'll have to just find an easy way to route them. I did a very good job keeping everything neat. I know it doesn't look neat, but it is. Everything is very nice and looped. So I'll be able to come in and then with like a few seconds, just, you know, manage the cables. You can see how much better that already looks just by wrapping them up. So it's a little bit messy, but I'll be able to clean it up pretty well. I don't have the bed heater hooked up yet. I decided to leave that off because there's no point of wiring it. And one thing that's very controversial to me is I'm powering the Raspberry Pi with these headers right here. There's 4 connectors, and I think there's probably a better way of powering it. I have a feeling. So I'm not completely sold on that yet, but maybe in the future I'll have to get like a buck converter or something. I don't know. I've heard that you might run into issues with powering your Pi off of a board like this, but we'll have to test it. That's the whole point of this, right? Maybe it works fine. Who knows? But that's what the electronics look like right now. So what we have to do is finish making wires for this side right here. So I'm going to do that right now. Those will just be standard JSTs right here. So I'm being very careful not to damage any wires. And you want to do all this in order too. I'm doing stuff out of order because I was missing some parts. What connectors? For what? Right now I'm putting on stepper motor or driver connectors. So these are going to be JST XHs. Those are the 2.54 pitch. Oh, the Raspberry Pi. If you search like how to hook up a Pi to an octopus, I was originally going to use, what was it, UART connected, but I decided it was a pain when I had to take out the SD card to edit some files. So I'm just using USB to connect, but I'm still using the same power from the board to power the Pi. With my very preliminary testing, I haven't gotten any under voltage errors, but I'd be interested in monitoring that voltage and seeing what it hits under load. So we're gonna be stressing it out with like an accelerometer test, and we'll see if it passes that. And also to kick, the worst part about how I'm powering the Pi is you know how stepper drivers come with a little jumper, like a breadboard jumper. Turns out those are perfect for running, at least the lengthwise. So I'm powering my Pi with 4 of those. Not ideal. Those are like 30 gauge wire. I would not recommend it at all. But in a pinch, it is powering my Pi. Issue of powering Pi via GPIO pins is that you need a regulated supply. USB should be regulated. I'm not powering it with USB. I'm powering it with the 5 volts, regulated 5 volt output on the Octopus board. So it takes 24 volts in, and then it steps it down to 5 volts. Which is, again, not ideal. Hey, Sparky Face! Welcome on in. Fellow designer over... I don't design stuff. Designer over on Thanks makes some awesome stuff. Go check out their work. I've been pretty behind in printing, like fun things. I'm still working on this Christmas train model. It's about as far as I got. Maybe I'll have another part done before Christmas. Who knows? Is the output from the Octopus supply 3 amp? Oh, I guarantee it doesn't. We'll figure out proper wiring for the Pi later, and I'll make sure to update that. All right, we're almost done. I got these stripped, and all I have to do now is crimp on some JSTs, and then we'll get this thing up. Christmas of what year exactly? I could be printing out stuff next year. Guess what holiday's coming up next? Valentine's Day. If you haven't started printing your Valentine's Day stuff, ooh, you're behind. You are behind. Raspberry Pis are happiest with 5 amp. Yeah, a 3 amp 5 volt power supply is very ideal. I usually run a proper, like Raspberry Pi, at least spec'd supply. Not just a USB cable and a power supply, but a proper 3 amp 5 volt supply. It usually provides a little bit over 5 volts. So when the power rail gets loaded, the voltage drops to 5 volts, doesn't drop under 5 volts, which is pretty smart. What am I up to today? We are in the process of building this kind of, would you call this a mid-size printer? I don't want to call it a small printer. It's not small. It's definitely not small. It's like the same footprint, almost as an under 3. But for an enclosed printer, it's pretty small. So this is the Micron Plus. It's a 180 by 180 by around 150 to 165 in Z height. Perfect for miniatures, perfect for on-the-go ABS printing. Kind of when you need you have a lot of space and you might want to travel with the printer. It's a good size. It's a little bit bigger than a V0, which is this orange printer behind me. But it's quite a bit smaller than a full-size like Trident. It's definitely a lot smaller than that. In my opinion, 180 is a very good size. You can print some decent models with that. Decent size models. Bow and arrows. Yeah, Valentine's Day. Another pro tip. Did you know that designers probably have made designs in the previous year? So if you're looking for the latest Halloween stuff to print, or the latest Christmas stuff to print, or Valentine's Day stuff, check last year's models. Right? They're probably, I mean, if it's think about an up-and-coming designer you know, someone who only got famous from the last, I don't know, a couple months, check out their previous year's stuff. Maybe it wasn't popular. Maybe it's really cool. You'll be able to find some stuff if you dig deep. I know I have. A couple Patreon subscribers that I just downloaded all their files from. I'm scrolling back and they have some really cool stuff. Very, very cool things. $5-volt power supply for meanwhile, about $15 on Amazon. Space is a concern in this printer. Space is a mild concern. So whatever we go, or you know, whatever this thing goes with, I have a couple ideas, and I'm gonna play around with them and see what the team looks or thinks about. But I have some ideas. It's a printer for ants. This is quite literally part of the Printers for Ants collection. It's one of 2 printers designed from scratch. Designed with these 1515 extrusions, which are itty bitty. They're little tiny extrusions compared to the full size 2020 extrusions on a standard printer. Yeah, if you have any links, feel free to send them to me in the DMs. If you're watching this live. If you're watching on YouTube, another friendly reminder to like and subscribe. Also, check out my affiliate links down below. I use those to, you know, pay for some of the things you see on this channel, including electricity. But I'd love to do more stuff in the future, so the more support I get, the more I can do. And I appreciate everyone stopping by, watching, leaving comments. Having fun here. I have fun. Quite a few people run their Pis off of 2 5-volt ground connectors from the Pico. Really? Huh. I'm sure this will be fine how I have it wired. I don't like the wire gauge. I'm assuming there's going to be quite a bit of drop off at load, but we'll try it out. Sparky Face, almost at 2K followers on Thangs. Awesome. Drop your Thangs link. Let's see if we can get that up a bit, because you have some really good models. Truly, truly good models. Just 1 of 5. Thank you for the raid. Welcome on in. What were you working on today? What were you doing? You make a lot of cool things. I'm jealous. A lot of electronics projects that I wouldn't even know where to start with. All right. Let's see if we can wire this up correctly. I'm dreading. I dread putting in these connectors because the wrong way. I gotta take them out, and I hate deepening JSTs. So I think what I'm gonna do is steal one of these connectors, steal a motor connection, and then just take a look at it. There you go. Sparky Face posted a link in chat over on Twitch. Go and click that. Give him a follow. Playing video games. Nice. Nice. Perfect. That's always fun. Use the buck converter for your Pis. Yeah, buck converters. I know West3D sells one. Actually, I might have one around here somewhere. I definitely do have one around here because I never used it. Vacation mode. Yes, it is the holidays. Remember, if you're thinking about buying some 3D printers or printer accessories, check out West3D. If you're looking at buying a printer, they're actually stocking the Neptune 4 Pro from Elegoo. It's a fast clip-rise bed slinger that I've heard some pretty good things about. So if you're interested, give it a look. All right, I get the blue connector on the white pin. Okay, so blue connector on the white pin. So I'm just orienting this. I'm using some reference cables just to make sure that I'm plugging it in exactly how it was, because I'm just extending it. So I want this to be extended properly. Got several. Okay, I'm gonna play around with this configuration because I've actually never powered a Pi like this. So I'm curious, but yeah, I'll do some testing on this configuration. If you're actually, if you want, let me do one more pinout for this, and I'll show you something cool. But this printer is now live to configure. I went over this on stream the other day. I don't know if it was on a YouTube uploaded stream, but I stream a lot on Twitch just for fun, not recording for content. Because I think it's more fun to just stream on Twitch sometimes. All right, those are both in. Let's take a look at West3D. Sit down for a second. All right, so West3D, if you go on their site, I have a link in the video description. They have the Micron Plus configurator. So this is what we're building. Hello, Stone Monkey Research, welcome in. So this is a configurator. West3D is one of the only companies that I know that really goes, they go deep into the customization of whatever the heck you want. Because why not? If you're buying stuff anyway, you might as well be able to customize it. So West3D will offer a configurator, and you can select whatever parts you want, what parts you don't want, save some money, etc. For example, if you wanted to get this Micron Plus 180, you can pick your own frame color using any of the DLL PDF frames. So they have a ton of colors, check them out, but you can get whatever color frame you want. You can even get printed parts if you wanted to in their new Ambrosia ASA, which I'm using the blue on for this build. You can pick a mini self burner, or I would just go for Dragon Burner, probably. I like Dragon Burner, how customizable it is. Hot end, pick whatever you want. The Rapido high flows would be perfectly fine for this. I would recommend that. You can go with Revo if you love Revos. Probes, it comes stock with a micro switch, so you can do regular clicky. At the minimum, definitely upgrade to PCB clicky. That is 1000% worth it over a regular printed clicky. It's going to give you more repeatability, and that's something you want with a printer like this. So PCB clicky, I've gone and done Boop, which is a nozzle probe, but just for the heck of it, I would recommend starting with clicky and then maybe upgrading to Boop in the future if you're unsure about setting up Boop. It wasn't actually that bad. It was pretty damn easy. Build plate, you can go with stock or magnetic bed, which has built-in magnets. This is a pretty nice upgrade, and you'll be able to just slap on your sheet without a magnet. Either way will work pretty well. For motion, you can upgrade. If you're planning on using this as a high-speed production machine, it's worth looking into the motion upgrade. So using the official gates, pulleys, idlers, and then this high temp belt, that could be worth it. They also have the Galileo Z upgrade, which you can do to increase your Z resolution. It's a pretty cool package if you're looking to try something new. And then they have their Berserker bearings. So I've used these in a couple builds, and oh my god. Every build that I put Berserker bearings on, these are the ceramic bearings. They are crazy smooth. It's noticeable over standard bearings. So that would be a fun upgrade. And then for your relay, get whatever you want. Get an Omron Panasonic. Won't matter too much. But that's it. That's it. There's not a lot to customize here, but that's the majority of the build. And everything else you'll get as is. Yeah, you get the... Actually, you get Berserker rails by default with this build, which is already nice. Panels. A big screen, which I have to install. Maybe we can do that on the stream if we get a little further. But check this out. If you're not interested in the Micron, maybe want to build something a little bit more cost efficient, look into the Trident configurator. So there's a self-source Trident configurator where you can pick your size. I'd probably go for a 300 if you're going to do anything. Whatever color frame you want. These are LGO frames. The blue is really nice. Printed parts, just like the other printer. Fasteners, you can get black or stainless. Definitely get fasteners with your build. Motion, you can get the standard, you can get pouch, berserker, etc. You can go through this whole thing. For this build, this configurator for the Trident, you can customize everything. Pretty much everything. Go crazy. Maybe you only want a... maybe you don't want a Rapido high flow. You can pick whatever you want. Save some money. Go with the CHC Pro. You know, save some money here, spend some money there, but really optimize it for what you want. And that's the key. If you just get an LDO kit, you'll have everything you need. But maybe you end up swapping out parts. It would have been cheaper to go with this configurator, building it exactly how you want from the start. So if you're experienced with 3D printers and want your next option, check out West3D's self-source configurator. Man, I wish I had that when I was building my 2.4. West3D did help me build this. They sponsored some of the parts, but I still had to do all the research, figure out exactly what I needed, and it was not fun. I would have rather just bought a kit. So, we are pretty much ready to have this thing homing. Yeah. Almost ready. So I'm going to flip this upside down. It's probably the easiest way to work on electronics. Flip it upside down so you can look down into it. And so nothing slides around. If it's loose, shouldn't be sliding around. In fact, I'm going to tighten up a few of these because I was trying to see exactly where I wanted to position things, and it was easier to have them loose and tighten them. Let's see if I can tighten these. Should be able to. Make sure if you're ever underneath here, turn off the power to your, unplug your printer. Don't just turn off the power, unplug it. The last thing you want is to run into an issue with power going zap. All right, so I have no idea which cable is which. They're not labeled. That'll be fun. That'll be a lot of fun. I'm just gonna guess. Your A motor should be going to the Y, and your B motor should be going to the X. Which one is the A and which one's the B motor? Pretty easy. I recently learned this. So your A motor's on this side, and the B motor's on this side. So if you're looking straight at the printer, your A motor is on your right and your B motor is on your left. Please correct me if that's wrong, but that's usually the case for these configurations. Usually. But, you know, I've been known to be wrong. And 4XY is still intriguing. So, I think we're ready. Ready enough to send it. There's more cable management, obviously, to do. But I think we're ready to... Oh, LEDs came out. Let's make sure nothing else came out. Oh, I never plugged this Z motor back in. Boom, caught that. Good job. I don't even know what... Okay. What does the LED do on the tool head? Does it actually do anything? Are there LEDs? I don't see any ports for an LED anything on here. I have no idea what this LED connection is for. So I'll have to look into that. But I know where it goes. I'm not going to plug it in because I'll have to look at the pinout. LED, who knows? Probably goes to some lights if I had to guess. But I don't see any lights in that pancake board. All right. Yes, if you want to subscribe to Twitch with Amazon Prime, you can. It's free. You get 1 free Prime sub per month. Make sure to use it. Use it anywhere. Use it here. Use it on your other favorite channels, but make sure to use it. Don't forget you have that. Every little bit goes and does help out streamers. That's one of the reasons why I stream on Twitch, because it allows me to do all of these things. All of the things. No, Mad Cat. Okay. I think we're ready. We're going to power this on. And unless I miss something completely drastic, we should be good. Just one thing we need to do, just one, and that is set up sensorless homing. That's on. Let's jump into the printer. Oh, there's a screen too, but I got to install a mount. Where'd that mount go? Oh, this one. This is the mount that I need for the included screen, most likely. Hello, Maker Viking. You're about to see first full home, I guess. See if this thing connects. Powered on. So we're inside of main sail. I want to change this. I named it Micron. It should be Micron. If you hit the gears in general, you can rename your printer here. So it shows up right there. So inside we have the machine. And we have printer.config. This is a very, very early config. I haven't done much to it. Wow, main sail is way out of date. Damn. Okay, we'll have to update this stuff later. Welcome in, Fat Baby. How are you doing? So we have, this is, I think it's straight from the actual Micron Discord. Not Discord, GitHub. I think this is the stock config. So I went through and I set it up for a 180. So we have the MCU. Once I flashed it, I was able to grab the serial addresses and post that in there. I have left I left this alone. All right, the first thing we have to adjust is our stepper X and Y. For this build, we're using sensorless homing. Let me zoom in a little bit so you can actually see. But we're using sensorless homing. So there's some interesting things that come along with sensorless. Makes me nervous seeing all this. It's very, very, very simple. And honestly, it's not too bad to learn. Like I hate programming. I can't physically program anything, but I can change a couple values in a printer.config, or at least walk someone else to doing it. Oh, okay, this doesn't have anything set up for sensorless. I gotta figure out what printer I have that I can steal my sensorless config for. Probably the V0. Let's see if I can plug that on and then SSH into that. Not SSH, but just pull it up. So what I typically do is I borrow config settings from other printers because that makes the most sense to me. I've already had it, it works, might as well use it. Let me try to get this plugged in. I can't wait to get this V0 tuned in as well. It's not as practical as a printer, but it heats up faster than all my other printers because of that small bed. And it has no probing, meaning if I just need to print something, the V0 is probably the fastest. Assuming that the parts fit on it, it's the fastest printer that I own. Meanwhile, the Bamboo says, yeah, I'm gonna do 10,000 calibrations. It's like the equivalent of sports ball, where you spend half of the game just like warming up and setting up and planning. Maker Viking just finishing up upgrading the Anycubic console linear plus delta with a new mainboard stamp clipper. Nice. Very nice. Oh yeah, there you go. There's some config settings. Oh, I need the diag pin. Shoot. What port is this? Okay, so yeah, we're gonna need a little bit more. I will copy and paste that because I'm lazy. So let's put this right here for now. Oh dear, it's straight copied and pasted. So UART pin, run current, cell chop. Cell chop, that's funny. So there's two ways of printing, you can either print with Stealth Chop on, which you set it to 9999999. Stealth Chop smooths out your stepper motion, makes it really quiet, but it reduces the maximum speed you can print at. For most people, it's probably fine, but if you're really trying to push your printer, turn Stealth Chop off and turn it into spread cycle mode, which is still pretty quiet, but yes, you can hear it. You can actually hear the motors turn. Try them both out and see what one works best for you. So, the issue with sensorless homing is you'll have to find a few things. Not really an issue, but to set it up, you need a couple things. The driver, whatever the heck that is how sensitive your motor is to homing. We're going to set this at 100 for right now. And then we also need a diag pin. So I usually put that right here. So we need this diagnostic pin, which is usually the end stop pin, if I remember correctly. So going into the manual for the board, I'm pretty sure this is a really old manual from Big True Tech. This is an old board. So we have these end stops, and these should be. Hey Eddie, welcome in. It's how sensitive the driver is, not the motor. Okay, yes, that's the proper terminology, because it actually detects. Oh God, I don't know. You can probably explain it better than I can, but it detects more or less lost steps. But sensorless is a pretty interesting resistance. Oh, yeah, actual resistance. Okay, cool. It does weird things. Can I not zoom in on this? Just do your best. Just do my best. I can do better than this, though. Okay. Yeah, sensorless, Stealth Chop, Spread Cycle, sensorless homing, they're really cool features by TMC, and it surprises me that Bamboo didn't use that. They went with their own custom stuff, and I guess you can, but we're just so used to all these TMC drivers, which is fun. Okay, I have no idea what's going on here. I'm looking for the diagnostic pins for an octopus. It's for sensorless homing. I can probably just Google it, but that's no fun. Wow, why can't I? Okay. Weird things. So, okay, end stop 0, 1, and 2. Okay, so my X is 0 and my Y is 1 for end stops. There's a lot of weird stuff that Bamboo does. Like, why'd you do that? Why? So our X diag pin is our end stop pin, which is P. Oh God. PG6. You could probably also just look on the actual control. So another way of doing this, probably the easiest thing to do, is our end stop pin. There we go. Our end stop pin is actually the diag pin, I believe. Oh shoot! I need to set my sensorless jumpers. Okay, I gotta do that too. So PG6, and then just to verify, we have that must be PG6, and then PG9 for the Y. PG9. Okay, cool. So I'm gonna take this end stop pin right here, and I'm gonna put it under diag pin. And then for our end stop pin, we need to change that. We need to change it. Which one of these 1,000 tabs is this one? V0. Is this the V0? Yes, okay. So under printer.config, we need this. TMC 2209 Sepper X virtual end stop. And this is correct because we are using TMC 2209 drivers. How many tabs do you need? All of them. All of them. So that will tell it, okay, our end stop pin is this virtual end stop, which is set up kind of here. So these two things you'll have to get set up. And I'm gonna delete this because that's not needed. All right, cool. So that should be everything. Then we're gonna repeat the same thing for the Y. So for the Y, our end stop pin is PG9. So our diag pin is going to be PG9. I'm gonna copy that and delete it. Okay, our end stop pin is now going to be TMC2209 Y, except for Y. Okay, and then we need, oh, I've already pasted, oh no, that's self-chop. So we need driver, whatever that is. I'm gonna set it at 100 for now, and we're gonna tune this. I'll go through the tuning process. So for sensorless homing, our rule of thumb is your homing speed should be equal to your rotation distance. Oh, that's interesting. Equal to or greater than. So, oh yeah, 32. So we're using 16 tooth pulleys on this build, not 22. So rotation distance is different. Interesting. So I'm gonna just do the same thing I always do, and oh man, should it be 32 or should it be 40? I always do 40. Let's try 32 for the homing speed. Just to start. So we're gonna set the homing speed for both the X and Y to 32, matching our rotation distance. Our position end stop is at 180 for the X and 190 for the Y, so it'll home in the back corner. Cool, I think that is set. And I also turned off the printer. Why did I do that? Okay, I'm gonna copy this config because I turned off the printer as I was editing the config. So I gotta set my jumpers. So because I'm using sensorless homing, I need to add 2 additional jumpers, which are usually near either the driver or wherever. I think they're those little pins above the end stops. The octopus board's really weird. It's laid out interesting. The faster you set it, the more likely you are to get a false positive homing. You set your super low too. Okay, that's what I usually do. It depends. There's a lot of variables that seem to affect sensorless homing. I don't know. I've had good luck at fast speeds for some printers, slow speeds for other printers, but my favorite has been just the stock, just slowest possible speed that you can home at. And then you can go even crazier and do a custom homing macro that lowers your current for your motors. And that will help increase the sensitivity. All right, so I just jumpered in these 2, which I'm guessing are the right things. Let me verify them. The board. Are those correct? I don't even know like where that is. I don't even know. Band 0. Well. When you go fast, I wonder if you can go faster with a looser belt. Yes. Like my rooks, for example, I have to go pretty slow because I don't know why, but they're pretty high tensioned. Like it just feels like they're higher tension. I don't know why. So we're looking for these pins right here. I don't know what the heck they are. I think these are the pins that we want to jumper to enable sensorless homing. Which if we go up to here, up to here, they don't. Okay, I saw it somewhere. I'm pretty sure it is in here somewhere. Wiring, automatic relay, BL touch, power loss recovery. Has anyone actually got one of these working? I'd be interested in in seeing this. I've always been interested. You know, if you have a very, very minor, like, brownout, I wonder if this would be significant enough to help. If you go on the Voron sensorless docks, they have a macro you can copy to lower the voltage. I will have to try that out, because I've always wanted to. RGB, Raspberry Pi, this is how I wired mine. It gets wired, like, to here. It's weird. I don't know. Inductive probe. Ah, shoot. Step direction. UART mode. We're in UART mode. Oh, okay. Fan, proximity settings. Come on, we're almost there. Stall guard, that's what it is. Thank you. Okay. Stall guard. The diag jumpers, which are used to connect the diagnostic output pin to the end stop inputs. That's what we're doing. So we're using the end stop. We're reading the end stop pins, but we're feeding it the sensorless or the diag pin. So that's what these are. The exact numbering can be found by looking at the pins file or a silk screen. Oh, thank you. That's super helpful. Thank you. I'm just gonna guess that's the first two. I gotta guess. Like, why can't you tell me? Come on, just tell me. Tell me why. All right, let's get this power back on. And then we'll see if we can get some homing done. We know that the Z works. Ironically, I got the Z working first. And then I got the rest. So I'm just going to copy up all of this, the whole entire printer.config, because we just turned on our printer. Yeah. Sometimes I forget about that. If you have to leave, I understand. Thank you for watching this live. I appreciate it. If you have any suggestions for stuff that I might be doing incorrectly, please feel free to leave a comment in the description or in the live chat. Preferably in the description so I can read it later. So let's go back into here, copy everything and paste, because I just pasted that. Something that I have that I personally do is I put in a little PID calibration macro section that all it does is just, I have PID extruder and PID bed, and this will PID tune to whatever setting. It's just a macro, so I can go in and just click it instead of having to type in, you know, PID tune, whatever. It's just useful. Thank you for gifting a tier 1 sub to Maker Viking. Very appreciated. So there's my PID extruder and then bed. Right now I don't have a bed, so nothing to calibrate. But now we can try homing. So let's see. Do you want to see if this will home? So the Z works, but let's see if it'll do either the X or Y. This is at a value of 100 for sensorless. And there's a ginger in the background saying hello. Oh, I should have tested the directions first. Why did I think that would just work? So it went the wrong way for the X and the right way for the Y. Okay, let's see. Let me see. There's an initial startup check that'll tell me which direction it needs to go. There's also a 0G thing now. Aha! See, always, every single time, every time. My X went this direction and my Y went that direction. The steppers are swapped. No amount of inverting will fix this. So I actually have to physically switch these steppers for them to work. So I gotta unplug the printer, and swap those connections. And that's what I was afraid of. Well, not afraid of, but... Hey, it moved! Did we see movement? That was our first powered movement on the printer. Yay! But now I get to flip around some connections. So our wiring extensions worked. That's good. I never know crimping on stream how that works because you get distracted, you crimp the wrong thing, you crimp over insulation. Ugh. Okay. Should be good to go. Turn back on the power. I like this inlet, although I'm a little conflicted. The light is always on, whether or not the printer is powered on. So when you plug in power, the little status light turns on, which is great because you know you have power. But sometimes I think the printer is powered on, but it's not. So maybe I'll have to add a bunch of LEDs. I got some strips that West3D sent over. These little mini, these are the rainbow matchsticks by Blam. We'll have to mount these on once the printer is powered on, right? LEDs are important. Something I'd probably recommend picking up if you get a printer like this. LEDs are fun. Let's go back here. And let's try to, okay. Whenever I'm home for the first time, I move my printer towards like the middle of the bed. I think I'll do some inverting. So let's see. Home all. Yeah, it homes to the right. And then front. So if it does that, that means both steppers are inverted. So I have to go into the config and invert our step. Okay, I swear to God, I do this every single time. Every time. Oh, wait a minute. Uh-oh. Is this one of the printers where it doesn't take a firmware restart command? Uh-oh. Alright, what do we do here? I forget how this works. So neither the restart or firmware restart does anything. Restart clipper? Like, I don't have to physically power off the board because it's also powering my Pi. And I want to go underneath there and hit the reset button. Okay, restart clipper and then... Okay, restart clipper and then restart firmware. Okay. Is there a way to fix that? Does anyone know? I do have the restart method command enabled. Maybe get rid of that? I'm not sure. So let me try getting rid of that, and next time we break something, we'll test it out. Also, you'll get a lot of these random printer config things. You can get rid of those backup files by clicking this gear and then doing hide backup files. This gets rid of them. I also like to do files all, so it shows every single one of my files in this page, so you're not losing them. But let's try this again. Let's go to here and try it. Wrong way. Okay. What happened was I didn't actually update my printer config. So I'm going to do that. Change my... Did it home the Z? Hold on. What did it do there? End stop Z still triggered after retract. Okay, we'll take a look at that. Maybe... Yeah, okay. I think this... Is it the board? Ooh. Is it the board? Maybe it just got unplugged. That's very possible. Oh! Aha! I was using the ground from the LED. So when the LED got unplugged, it disabled that. Okay. What even is the LED for? I think that's what happened here. Let's see, where's LEDs? LEDs. I'm guessing. I don't know. So it is 5 volts on the outside. Okay. 5 volts on the outside. This is 5 volts. You are 5 volts. Let's see. Does that fix it? Yeah, it does. Woo! I'm an engineer. I can solve things. Okay. Let's go home. Let's see. Let's find this page, and so let's change the direction. Oh, hi. Direction to the opposite, and then direction to the opposite. Every single time. Hot plugging. Hey. Shh. We're not hot plugging things that matter. Every single time I build a printer, the AB motors are reversed, and then everything's reversed. I just go in and reverse everything. Like, it's a skill issue, I guess. All right, is it gonna work? Let's take some bets. Is it gonna work? All right, so our Y seems perfect, but we need more beams on the X, which is actually correct because we only have it. We have them both at 100. 100 value, whatever that value is. So let's change our value to 90 for the X, and then see if that home's better. Sounds like a you problem. Hey, it's a partially me problem. All right, try this again. I'm just happy that the boop works. Boop. Not that boop. Wow, this is like perfect. Look at that. That's perfect. It's cool. Is it homing in the middle of the bed? Yeah, it is. Now it's homing too far forward. I don't understand why. Oh, is it because the bed needs to move forward? That's possible. I just kind of YOLO'd the positioning of the bed. That's the wrong size driver. So let's move the bed itself forward. Yeah, that's a smart thing to do. So if that's a half, let's center it on. That's how you do it, right? You center it on the nozzle. Totally how you do it. Let's move the Y to 0. Oh, did it hit the front there? Pretty sure it hit the front. Let's rehome that Y. It's set to 190 as our max travel. Oh, what's going on here? What's it actually hitting? What is it hitting? Oh, what is it hitting? What is it hitting? Excuse me, what? Oh, okay, it's hitting the, these things, the rails. The rails are hitting the stops down here. Okay, smart. So if we go to Y equals 5, yeah, we don't have that much play here. So let me go back into this configuration, and I think we can go to, let's see, 3. Yeah, 4 is too much. So Y equals 2. So we have to reduce our TLDR. Actually, let's just do it because we have boop, doesn't matter. Let's just remove 5 from our Y. So our position end stop is 185, and our position max is 185. And I haven't tested the X yet. So let's try that. Okay. So homing all. Ugh. Rattling the loose nuts. Okay. Now we can go to X or Y equals 0. and then position the front of the bed so it's just over the nozzle. And I think that is perfect right there. So I'm going to send it. This is just a, you know, a very sanity, not sanity, just quick and dirty, get the bed kind of where it's supposed to be, YOLO type of thing. All right, do we send a quad gantry level? Is that gonna work? Let's try it. Where is it? Oh my God, it is like on the edge. Ugh. It's like on the actual edge. What the heck? So we might have to center our X a little, but it's like, oh, it's on the edge. Okay. I don't like that. Hey, it's working. It is quad gantry leveling. We got our motors right. But it's literally on the edge. Wow, this is all right. This is good. This is good. Typically, you'll have a PEI sheet here, but I still think we're a little aggressive on that. I don't know what the stock settings for quad gantry level are set to, but I can tell you I'm going in and immediately editing them. Notepad. I actually do have the PEI, but I'm not gonna lie, I didn't want to destroy a brand new PEI, so I didn't put it on yet. And you always want to probe your bed surface if you can. Always probe it before you put the magnet on. That's a light pro tip. Get a measurement of your bed before you apply anything, so that way you know if there's a major warp, etc. Because you could have an issue due to the magnet install. Now this is taking a little while to properly tram. I haven't broken in this setup. Plus, remember, we're only on 2 rails, so I don't know how accurate we're gonna get here. Or not 2 rails, but 2 bolts holding in boop. I'm surprised it's actually working, but we're gonna at least get it somewhat level. All right, so in Clipper, we probably maxed out. Gantry corners, I'll leave those as is. Yeah, probe point 2.2. Why? Why did they set that up as 2.2? That makes 0 sense. Who did that? Who? Was it Heart K? I doubt that. But these points... Oh! These points are for clicky. Aha! Okay, never mind. Clicky. So we need to do 10... I'm going to do 10, 10, 10, 170. 170, 170, then 170, 10. There we go. That's why it was expecting clicky. Although I don't know why I was probing on the edge. That doesn't really make any sense. Ah, who cares? All right, speed, let's set to 600. Horizontal move Z, we'll set to 10. Retries 5. Retry tolerance. Sure, that's fine. Okay, try it again. And I guarantee if I look at the dashboard, it'll say, yeah, we aired out. Oh no, it did it. 3 out of 5. Oh, it actually leveled the bed. Wow, cool. Let's try that again. So we're able to home our X and Y at max position. Oh, that's slow. Maybe I will increase it. Our Y looks a little aggressive, so we'll have to tune that. Let's do that right now. Printer.config. Let's increase this to 105. Set printers with sheets you've already destroyed. That's smart. That's very smart. I would recommend that. Oh yeah, this takes Prusa mini sheets. That's awesome because I get a satin sheet finally. I can finally try a satin sheet. All right, one more. We're testing to see if the Y, it'll kind of jump at the end. See how it lost to like maybe like 0.5 millimeter or 1 millimeter? We want that to be as little as possible. But for this, we're using boop, so it doesn't matter. Let's try quad gantry level again. Oh, is it homing in the hole? Oh no! it's homing in the hole. Of course it is. Let's just how do I stop it? Oh geez. You know what? I think we'll put the sheet on because it's literally homing inside of the hole. Out of all places. Putting satin on a 250 Trident. Awesome. Definitely want to try one out. I think it's still kind of close to the edge. Maybe my X isn't set up correctly either. Because it feels like when it's on the other side, it's a lot closer. Maybe not. Let's move it in. Maybe 1550, at least for now. When we have the sheet on, it won't matter. But let's just move, where is it? Quad gantry level. Points, let's do 15, 15, 15, 165, 165, 165, and then 165, 15. So 15 from all the edges. Assuming that the bed is actually straight. Alright, and why is it moving so slow? Oh, max velocity 300, that's why. There we go. Max Excel, we'll set that to 10K. Max 4000. Oh, you. Oh, you. Oh, we have to increase our motor. Oh, 0.6. 0.6. Oh, no, that's far too low. Let's bring this to... We'll start at 1. Oh, man, we have to redo our sensorless config. All right. Let's bring it to 1.2 amps for the motor. Literally doubling the current. There we go. And then we'll retest sensorless homing to see if that works. And take off this nice, beautiful bed. The West3D beds are quite nice. These are their black, double-sided, so the side's smooth, and then textured. It has a very nice texture to it. I really like it. So I increased my motor current. So what's the odd of these sensorless values working the same? X works, and Y is not what do you call it? Y is not correct. Too sensitive? Not sensitive enough? Not sensitive enough. Let's change that to 95? What was wrong there? X works fine. Usually does. Actually, I would like to see... Oh, what happened there? Not sensitive enough again. Okay. Weird. Weird how changing the current value adjusts the threshold. Now, they're both at 90. What was I saying? Oh, yeah. So what I would probably do for this situation is use sensorless for the X, but then add an end stop right over here for the Y. So there's actually a cutout right here. You can see it. That's where your end stop goes if you want to wire one in. And that'll make it so your X, you know, that'll usually home fine, but your Y will then home fine. And it won't lose like that one step that it just did. So I'm thinking about doing that on my 2.4 build, the tap changer. All right, so that's fine. Let's try QGL. There we go. That's a little better. Homing in a reasonable spot. Good, good. That is 600 millimeters a second at 10K. I I don't know why the stock homing speeds are so slow on these printers, but I guess it's better to be conservative. Oh yeah, I can see this whole carriage kind of tilting. I really got to, is that homing in a hole? No, it isn't. I gotta swap out my carriage on here so it's proper. So whatever you're seeing here is not gonna be the final probing. Although, oh, I'm gonna say it was close. I don't know how close it actually was. So how far away are we from pushing plastic? Well, while this is going, let's just make a config in Orca Slicer, just in case. Boop trips you out. Yeah, I know. It's weird. It's so weird. Retries aborting. Let's try that again. Yes, I get it. I get it. It's oh, is it? Oh, wait a minute. That front stepper. Okay. The front stepper might be disconnected or has a loose connection. So let's check that out. That will be this one right here. So turn off the power before you mess with anything motor connection related. And let's see. Which one is that? Interesting. I don't know. But you guys saw that too, right? It's like wasn't moving on one of those steps. Very strange. We'll try it again. Doesn't help that I have all these wires going nowhere. It's like, why was it aborting? Anyway, let's see if I can set up a Micron profile, because there's really not much left to getting this working. So what do I start with for a stock printer? I don't know. It's a 2.4 technically, but you could do anything. Let's steal my actual 2.4 profile. Let's do that. And I'm going to rename this to Micron Plus 0.4 millimeter. Well, it's a little bit more. I mean, yeah, technically it's a V0. Technically speaking, but we'll use my 2.4 profile. So set my printable height. Let's do it to 150. I'll do machine or change the printable area to 180 by 180. Okay. Beautiful. I'll save that. And then I will use my stock profile. Cool. Now, one thing I have to do is set my, well, we have to do the Z offset. We'll have to check that. But I have to set my bed temp to 0. We actually do a few things here. We need to get a start print macro going. Is there already one in here? All right, let's see if we can home this first. See what's going on with that. Oh dear. Oh dear, something is terribly wrong. What is it doing? Night, night, cat. Oh, what? What the heck? What the heck did I do? What's the max max acceleration? I don't know, I'll test it. Why is... What the heck? What is going on here? What did I change? That's some weird stuff on the Z-axis. I don't know. Did I change something I wasn't supposed to? It's always possible. Let's try increasing the currents a little. These are the big beefy motors. We can change that to like 0.85. I don't know if it's a motor issue. Interesting. Let's see if I can solve that. Because it was working fine previously. So I'm wondering if I adjusted a setting that I wasn't supposed to. That's always possible. You go through the config and you change something, you think you're in the right section, but you're not. Trailer home. Oh, now it's the X that isn't homing correctly. That's just the crash. Is that over the bed? That is. All I did was increase my Z current, and that seems to have maybe helped it. But I have to increase my Y. Was that the Y? Or is that the X? I gotta increase my my X sensitivity. So I'm at 85 now. Let's go down to 80. That's why you want to run that the macro that reduces the current, because it's easier to tune with lower motor currents. When you go with really high motor currents, it doesn't detect the stalling correctly. That's what I've noticed. Okay, that's fine. Good enough. Okay, that looks better. Let's just go up to 150 and then back down. Make sure everything works correctly. Okay, just a little bit low on the Z current, I guess. All right, let's do a QGL. See if that still works. Oh dear. Huh. Something is not correct. So something is not correct here. So I will have to figure that out. What do you guys think it is? What do you think the issue is here? Is it a physical issue? Or is it something else? Let's just tilt it upside down. Oops, can I do that? Not really. All right, let's see. So checking, which one is it? It's, okay, is the belt slipping? I don't think so, because it's providing tension. I don't think it's slipping. And the motor does seem to be plugged in correctly. I know the wiring doesn't have anything like clean up your wiring. Yes, I know, clean up the wiring. That's always potentially an issue, but I'm just wondering why. I don't know if the drivers are overheating because I don't have any cooling on them. That's a possibility. I am driving the Pi. I am driving the Pi with potentially under voltage. So I don't know if that would cause an issue. Although it would usually show up in Clipper as like, oh, actually, there we go, yeah. Power supply dropped below 4.65 volts at least once since power on. Interesting. Interesting. So yes, if you were wondering, running it, as I said earlier, running it how I had it is not ideal. So let's see if I have a proper power supply for this. I think I do. This is an old one that takes, yeah, micro. So let's just power the Pi separately and see if that will be any better. Because yeah, this wiring is not ideal. So I'm wondering if it's the Pi that's throttling and causing the, I don't know. I don't know why that would cause that issue, but we could test it. Certainly. So I'm going to plug in the Pi. I'm actually going to take it out because it's just connected via USB. So I'm going to power the Pi separately and see if that helps. Because all the connections seem fine. And it has been working fine. So I wonder why it would just stop functioning as intended. Just like that. What do you guys think? Let me know in the comments. What did I mess up? And remember, this is technically a beta build. Hey, Gulsifer, how's it going? We're doing some little bit of troubleshooting right now on the Micron. Trying to figure out why not all the Z motors are moving correctly. And thank you for the subscription. I had a power issue. Well, this printer wasn't plugged in. So let's see. Oh, I didn't actually, I got a power on the board. So ideally, I would love to have like a second power supply, like a second switch just for the Pi, or like a separate power supply for the Pi, almost running it externally. Just because sometimes you want to reset or unplug some stuff, but you don't want to have to turn off the entire Pi. Like, what if I want to disconnect the stepper motor and then quickly just plug it back in? I have to restart the whole entire Raspberry Pi. All right, so let's try a home all. See what happens. You have your Trident set up that way. Yeah, I'll have to. I'm sticking with a mostly stock build for this, so we'll see. Oh, it's still doing it. See that front stepper? Front stepper is not responding. Is it spinning? No. Okay, so that rules out that, yes, the Raspberry Pi is, I'll have to have that powered properly. What could it be? It looked like it was multiple dead motor. Motors generally don't die. That's like, I'm not gonna say impossible, because it is possible, but it's extremely difficult to kill a stepper motor. And these are brand new, so I'd be very surprised. So it's that one. Just triple checking all the wiring here. Now what I'm gonna do is swap drivers. So I'm gonna swap my drivers out and see if that's a potential issue. So let's just swap two of the Z drivers, the physical drivers. I'm hoping it's not some like random config issue that I just touched, but it seemed like it was multiple things happening, so I don't know. I am just as clueless as you guys. Try it again. Very first orbiter today? Yes, orbiters are very nice. I was almost going to go with an orbiter for this build, but I decided to test out the stock included gears, which they work fine. Oh, well, I haven't tested these ones yet, but they install fine. Firmware restart, let's see if that works. Let's try another home. So it seems to go up fine, but down. Okay. Let's just go up and down a little. I swapped my two drivers, like Z0 and then Z1. Honestly, could be a connection issue. I'm also wondering if it's an overheating issue because I don't have any fans plugged in yet down there. But I've never had the Z motors just fail like that. So could be thermals. I have some fans to plug in. I will certainly be doing that soon. But I just wanted to test that without the fans first. Usually it's the AV motors that fail, they overheat. So let's try a quad gantry level, see if that works. No. No. Same one. Okay, so stepper motor or driver, nothing changed. I don't know what else to check. Seriously, I'm kind of lost here. Swap the driver. Yeah, what else? What else is there? Checking config. Did I mess anything up inside of the printer config? So I swapped over the diag pins for the X. I'm running all the Z motors at 8.5 steps. Oh, grub screw. Could it be the grub screws that didn't Loctite? Could it be? Could it be? I didn't check to see if the actual motor itself was spinning. Let's see. Let's see if we can check that. That could very much be it. Yep, that could be it. Because I still have to go through and undo all that and re-Loctite it. So let's see, which was it? This one? See if I can move that stepper by hand. Hey Pico, how's it going? We're doing some troubleshooting now, and it could be grub screws. Grub screw related. So I'm moving it by hand. It seems fine. Putting quite a bit of force on it. It's not slipping. It's not slipping. But I don't know if it's a grub screw. But worth checking. Grub screws are tight. Usually those loosen up over time. So yeah, it seems like they're on there pretty good. So not a grub screw. Good check though. Use clipperize your printer. Nice. Awesome. Which printer? Yeah, I don't really know what else to check here. Only thing I could try is just unplug and plug it back in. Blow on it. Usually helps, right? Unplug it, plug it back in. Binding. I was also checking for that, but it seems like it runs smoothly. Like, I don't know what it'll be binding on. And it only seems to be causing issues when I'm trying to use the boop probing. But let's test it again. One more time. Let's document as much as possible. Because, hey, someone else might have the same issue. I almost like running into issues at times because it allows me to learn from the mistakes. Because maybe I made a mistake. I don't know. Who knows? Can't manually move this up and down, can I? I guess not. The Z's are like, the Z, I can hold this whole entire gantry up by the Z. Incredibly high torque. Did you look at both the pulley on the gear and motor? Just the, well, I can see the teeth not spinning when I was doing that. But yeah, it could be the other one too. But I mean, I think it's fine just because I can't move it up and down manually. You can see it trying to spin the motor. That's pretty damn tight. And I just built it, so I'm leaning on probably not. But hey, let's try it again. One more time. So I'm watching through the camera, but I'm watching the stepper motor spin. Tensioning test in the Z. It's tensioned pretty tight. Yeah, see, it's just not. See it? It's just not. Is it just that motor? Is it just that side? Is your rail binding? That's a good question. It's not binding because I can move it by hand. It does feel like something is not quite correct. Buzz the motor. Okay. Loosen the rail. Yeah, I can. I can loosen it. Yeah, loosen the carriage. Try it again. I mean, I can see it kind of move, but let's try it again. One more time. One thing at a time. So I can see it lagged right there. That's the weird thing. It's like partially working. It's working there. Let's go in increments of 25 up. Yeah, very much could have been binding. All right, let's try quad gantry level again. It was failing when it was trying to probe in that front corner. Yeah, now it's... stopped. It just stops. It's not bottoming out anything. It's not, I can still move it, so it's not binding. The actual carriage isn't binding to anything. So I can still manually move it by hand. So I think it's something to do with the motor. Motor itself. Same. You think it's mechanical? It very much could be. Because when they're all homed, I can go... No, I can go up. Stop that. This doesn't have a lot of play. All right, I think we'll call it in a few. What else? I don't know what else I can really try. I swapped the stepper drivers. You don't see the carriage moving right. The carriage is completely free. Like, I can move it up and down. It's not binding on anything that I can see. If anything, it's the actual belt itself. So let me just check that. It could be, honestly, like a screw could have fallen in. That's possible. Something that's causing an issue inside of there. Let's turn off the control board. Take a look. This one, you can't really see anything inside of here. But I didn't really think about that possibility. Because, you know, something could have fallen through. How do I access that? Jesus. Is that even possible? What can I do to access inside of there? I kind of have to remove this stepper. That's the only thing I can think of. Was it only that one, though? I thought at one point I saw multiple not moving correctly. Did screw fall out? Yeah, here's a screw. Like I said, stuff has fallen on the deck before. And that's why you have that little... You're supposed to have a covers for the Z-axis that I haven't installed yet. For that reason specifically. So let's see if I can see anything inside of there. Because it was moving fine in the up direction, but not in the down direction. So that would potentially mean that there's a screw in there. I'm hoping that's the case. That would be ideal. Oh, did that screw fall out? Is that what you're saying? Jeez. Good night, everyone. Let's remove this motor. Luckily, it's not too hard to remove the motors. You just unscrew the 2 bolts and then loosen up the belt. And now I should be able to freely spin this. Yeah, it moves perfectly fine on its own. Now let's provide some tension on the belt. That's perfectly fine, no slipping there. So nothing that I can physically see. Definitely is smooth. I don't feel any binding at all. So let's reinstall it. Maybe there was a screw in there. Maybe it just fell out. Who knows? Oh, actually, hold on. I think I found the issue. I can't spin the motor. I wonder if I have the pulley too close to it. So let me loosen that up and see if that's the issue. That would make perfect sense. Well, I wouldn't say perfect sense, but make a little bit of sense. Maybe. Maybe it was just, So when I put all these on, to get them lined up correctly, I did press the idler, not the idler, the pulley. Where's the, let's focus, that's too close. I pressed the pulley against the motor because that's how it aligned. And you saw that I couldn't spin it, now I can. So that might be the issue on every single one of these, is that the pulley is just too close. Interesting. I wonder if that's the issue. Because that would explain the randomness of the binding. Like in one direction. Cool. Well, if that's the case, then we troubleshooted. If it's not the case, then I will be going to bed and not being able to sleep because the printer's not working. Oh man. Hey, one of my best tips, if something isn't working, just put it aside, step away, go back to it at a later date. You know what? You might have a fresh mind and say, wow, that was something really stupid that I missed. And that's fine. Perfectly fine. Where the heck did the nut go, though? It's up there. Preloaded nuts. Gotta love them. And yes, I know I should be taking this time to grub screw everything, but I have to undo the entire Z assembly to grub screw everything, so... Or not grub screw, Loctite the grub screws. So I'll be doing that at a later date, off camera. You don't need to see that. Let's try this again. Maybe some better luck. I'll leave that skirt piece off for now, just so we can kind of see it better. And I really got to tidy up this wiring. It's kind of hard to work with because there's so many wires dangling. So I'll have to get it all neatened up. All right. So that was the one driver that was the one side that was causing issues. If that's the case, then I'm gonna have to go in and loosen up all of those because I installed them all the same. And I think I saw some of the same kind of issue happening on some of the other motors. So if that's a note, then I'm gonna add that to or make a suggestion for the manual. If you're watching this, well, I'm sure you are enjoying the troubleshooting, maybe, hopefully. You won't though. I mean, if that does solve the issue, That's something very simple. Very, very simple. It's just the way that the belts are lined, but hey, let's see if this thing actually works. Nope. Not at all. Oh. That's because we didn't plug... I don't think we plugged back in the stepper driver. Nope. That'll cause an issue. Okay, that one's my fault. I didn't plug in the actual stepper motor. So, with power off, I turn it back on, or plug it back in. Oh dear. Is this spinning? Oh. You know what? You know what? Yep, I think that's the issue. Look how much easier it is to spin now. Aha! Aha! Yes! That's my issue. Okay. We're gonna undo this, unplug it. So, for every single one of these Z assemblies, I thought it was just extremely like easy to move around. Turns out the actual motors were binding, or the pulleys were binding. I would have never guessed that. So, yeah, every single one of these pulleys has to be moved a little bit away from the motor because it's binding up. Wow. Kind of crazy. I wonder if anyone else has ever run into that issue. If you knew exactly what the problem was from the start, cheers. Yeah, so this one isn't spinning at all. I can't physically move it down, but the front one I can. Again, I thought that I really thought that was just because it was a well-designed Z, but it turns out that I am the issue. Look, it's me. I am the problem now. Yeah, yep. That was it. Every single one of these. Okay. All right. Well, you learn. You learn something. Now how do I edit that out? Not edit it out, but like put a card saying, "Hey, skip to this timestamp." And you'll realize what the issue was. Yeah, that's crazy. Wow. I never would have guessed. Metal versus metal. Well, it's yeah, I guess so. I thought it would be looser. Hey, it's one of those things that as you're building, you just kind of do it and it makes sense at the time. And then you realize that, oh yeah, this doesn't make any sense. But all of these are spinning really good now. Question is, can I still lift the printer up by the gantry? Yes, I can. Okay. I can still lift the printer up by the gantry, but now it moves. Oh, I can manually move the gantry. Oh, awesome. Yay! We did it, chat. We did it. Let's get some hype in chat for fixing issues that I caused. And I will make sure to note that, because that's a major issue. Actually, I would state that as a wow, how the heck did you mess that up issue? Fun. If you'd like to purchase one of these kits, make sure to check out West3D. You can have your own fun while building it. Now, when you're building your own kit, make sure to watch through this entire like 10-hour long, probably more than that, build series. and catch all the mistakes that I made before you make your own. Enjoy. Let's see if I can mount the screen while I'm at it. Wow, that's simple, eh? That's simple. How much complete? Well, we have a successful home. We did a successful quad gantry level 2, which is even more surprising. So what's left? Well, as you can see, cable management. But I tend to not do a great job of cable management until everything is known working, for this reason alone. All right, Maker Viking, have a good sleep. Thanks for stopping by. What's left? I'm waiting on the heat bed. That is something that I want. I would like a heated bed. But that is being shipped over right now and will be definitely included in the final kits. Remember, this kit is a beta set of parts. The actual kit might slightly vary due to corrections or part availability. Let's see. This does not feel uber strong, but okay. We'll go with that. Wow. Remember not to use ball end screws to torque down stuff. I ended up getting these dedicated ball end wearers just to try out, and they're okay for some things, but I'd rather just not use them for the majority of stuff. All right, so that solves that problem. I'm gonna continue to power the Pi off of the board for now until I figure out a better solution. Or whatever was intended. You know, maybe there was an intended solution that I just missed. I'm actually going to document that now before I forget. And then let's see if we can do a better home. Who knows? Maybe it'll suddenly get much better. Oh, how much further? How much? This is an $800 kit. I guess kind of shown in this configuration. It's around 800, probably a little more with the boot. It's around 850. So this is definitely a hobbyist build. But you're spending almost as much to build a V0 in some cases. So it's a full 180 build. You'll get a much, much bigger build volume out of it. And a lot of people only use the build volume. You know, let's say you have a 250 Trident. How often do you print over 180? Chances are not that much. All right. Let's move the police. What was the question? Let me see if I can restart this. The firmware. I think I did a... Let's restart Clipper. Is everything powered on? Yep. Should be. And home all. Whoops. Oh, my camera's frozen. Oh, my camera's not frozen. Looking at the wrong screen. Watching my own stream instead of watching StreamYard. That's funny. All right. Let's do a full quad gantry level and see if it's any better. Now it's... Note that the boop isn't mounted 100% correct. but it's leveling. Even with those 2 screws mounting it, it's still able to level. That just goes to show how good of a system that is. Huh. I honestly, when I first heard about tap, I wasn't a fan. I didn't like the idea of adding a linear rail in there. It would cause instability. But I think a lot of people have proven now that this is a competent solution. And if I never have to ever adjust like clicky or do anything like, and it doesn't affect my maximum travel speeds and maximum accelerations, probably gonna go for this. I'm gonna end up doing what everyone else does and just switch over to tap. And I might switch over to this system right here on my big printers. So instead of self burner, go with a dragon burner and boop. With high-powered fans, about 12K RPM fans or so, the cooling on Dragon Burner is actually better than Self Burner. And since I print a lot of PLA, that's pretty useful for me. Only thing you found with tap is it dots the smooth plate. Yep, I typically don't use smooth plates. Now I wonder, is boop less aggressive than tap? Can you fit boop into a V0? Physically, yes. Will it work out well? No. The issue is the cantilever bed. It just won't work. You need a very solid base. Either a Trident style at the bare minimum or 2.4 style. Both of which exist as mods for a V0. But yeah, it's the bed. It's just the bed. If you convert it over to Tri, then yes, you can. But you will lose build volume with the... I believe you will. Not 100% sure. I think it's a little bit in the Y. But on the Y, on a Voron, you'll typically have over travel. And hey, we got our tolerance correct. Sweet. Look at that. Isn't the rail different size? Oh yeah, it's true. You need a front-mounted rail. A front-mounted rail for poop. I do believe. Don't quote me on that though. All right, well that's a thing. Well, let's just keep going. Why not? Let's set the extruder to 230 and do a Z. Like a Z offset tuning? I don't know. All right, thank you, Gulsper. I figured there's something up, so. Yep. Well, seems like we solved it. That's good. Now, how do I... Is it as simple as doing a probe? Is this a probe? Like a probe offset? Do I have to do a probe offset with clicky? Or not clicky, boop? Not 100% sure. I had a guide I was following. Probe calibrate. Okay. And then there is an activate G code that I have to do as well. So that'll set the temperature of the extruder up before probing. So I haven't been doing that yet. Actually, I haven't even torqued the nozzle down, which I should probably do eventually. I don't think we're going to extrude today and print, but I at least want to get it as close as possible. I don't have a heated bed either, so I'd have to like run around and find something to print on. I'm pretty happy with this as well. Why was your Z stuck? Okay, so the pulley was pressed up against the motor housing because that's how the alignment worked out to be. So it was actually causing binding on there, and it was inconsistent. All right, so let me add this on under probe. Activate G-code? I think that's where it goes. Ah, what's this? One of these two. There it is. It's on the other screen. Add to probe section. Okay. Probe. That is in the probe section. Cool. Our offset is all 0, 0, 0. I don't know what speed settings to use for it. I think that was debated on a previous stream, not ours. But we'll stick with 10. And then, so we'll home all. And then, okay, extruder temperature is too high, waiting for below 155. Okay, so it tries to go between, so it actually lowers the temperature. Okay, interesting. It lowers the temperature. Why would it want to do that? Lowers temperature. Max temp is probe temp plus 5. Okay. So it waits, and then it'll probe. Neat. So let's do a quad gantry level. It doesn't care at all because, okay. Do I have to put that in the? Do I have to put that same G code in the quad gantry level 2? I'm guessing I have to because it's not doing anything. So let's go into printer.config. And then let's do a, put that in, where's quad gantry level? Put it in there. I'm just guessing at this point. It doesn't say in the actual clipper config. Tap's not allowed probing when it's hot above 150. Okay, activate G code is not. Okay, so how? Huh. That doesn't work. Okay. The question is, why is it not heating up the nozzle to do a quad gantry level? That's what I'm wondering. I'll have to check that out. Oh, wait, is it just... I thought it wanted a minimum temperature. So does this just wait for it to cool down? Because you need a certain temperature for it to probe. Did you do the tap G code? I have this in here, yeah, and it was working. Look up tap docs. Yeah, I have. I'll have to look in the actual. Oh, I'm in the tap docs. Update your printer config. It's recommended clipper tap instructions, which I have. Run probe accuracy to break it in. Yeah, I'm still gonna do that, but once I replace the rail. We're gonna do probe accuracy tests. Yeah, I should do that too. I'm not sure. Doesn't really say unless I'm just missing it. But we can run a probe accuracy test. I'd be interested in that. Save, start. Tap will not. Yeah, it won't work above 150, but I thought it has to heat up in case there's molten plastic on there. Is that the whole point? You always set your pot in at 150 before probing. Okay, so you set a manual target of 150. That's what I was wondering. Because if there's cold filament on your nozzle, then that's not going to work out well. So it has to be hot enough to squish, but not too hot. Okay. Fuchsia slicer? No. Orca slicer. Fuchsia slicer. Probe accuracy, samples equals 20. Whoops, I gotta home first. Y is a little aggressive. I should fix that. Let's see if our probe is accurate enough for these tests. Look at initial bed temps. You have to export your variables correctly and then import them correctly. That's your issue. Deviation 0.008. That's perfectly fine for what we're trying to do. Perfect. All right, let's run a quad gantry level. So yeah, because we're at 150, it's fine. So what I'm wondering is, if I set it to 180, lower it to 150, and then did the stuff, would it wait and then keep it at 150? I'm not sure. I'm wondering what the recommended probe speed is for tap, because I've seen it done pretty fast. Right now we're at 10, and it's definitely within the right tolerance. But it's exceeding the sample tolerances. I don't know if it's the first one that seems to be different. It will lower to 150. Well, yeah, when I ran it manually, it just turned off the heater. So that's what I was wondering. Yeah, tap is interesting. I definitely want to play around with it more. I had this kit that I was going to put in my Trident, but I've never done it before, so I was afraid of messing something up. And that was a printer that I wanted working. Probe, yeah, so we're exceeding our sample tolerance, which is kind of expected. Just for the heck of it, let me go into printer.config and go under our, just for temporarily until we rebuild the gantry, replacing the rail on there. Let's change our retry tolerance to, I'm going to comment it out. Well, right now it's at 0.0075. Let's change it to 0.15 just for kicks. Okay. And then we get to try our extruder. We haven't even tested that yet. Let's pump one more time. And test our extruder. So let's heat up our hot end to 230. I haven't tightened the nozzle yet, so let's do that. Let's do that right now. Let's increase our Z height to 150. Target temperature 260. Grab my torque wrench and tighten that up. I do use the slice 1.5. I think a 2.5 would be perfect, but this is what they gave me when I won it. Oh yeah, the nozzle isn't even tight, so that could actually be an issue, like the nozzle loosening. I let it heat soak for a second, and then I tried again. I don't know if everyone else does that, but there we go. That is 1.5 Newton meters of torque. Now, let me do another Z home. Okay, so it's at 160. It's lowering temperature to 150. So it's setting the temperature to 150. And we'll see what it does. All I'm doing is a Z probe. Doesn't cool down fast enough, that's the issue. It's not about speeding up the... Actually, it cools down about the same rate as it heats up, a little slower. This bed is nice. I'm really digging it. I gotta put in these little screw retainer things. Maybe I can put those in now. What size? Just any of these socket head screws that are kind of short would work. Let's see what the shortest one I have is. 2x12. Trying to use the stuff that they gave. I have some more. All kinds of fasteners. Almost too many fasteners. Never such thing. Never such thing as too many fasteners. Could always use a longer one. But put an end stop on these two little screws right here, and that will help you align your bed once you install it. So now we get to do the best thing ever, and that is, so I'm going to increase temperature one more time to 230. Set our Z offset. I always set this high. I'm paranoid because I've definitely messed this up before. So I'll typically use a kind of a thicker sheet of paper to do this, and just make sure that the nozzle is above where it's supposed to be. And then when I do my first print, I'll baby step it down. So right now it doesn't matter what surface we're on because this is an offset. So if I put a PEI on top of it, then it's going to be the same offset. That being said, the bed should be at its final temperature when doing this. So right now our bed is not heated. Waiting on the temperature, waiting on the heater. So we're going to do a probe underscore calibrate. It'll home the bed. Oh, of course, it's going to lower the temperature back down to 150. I forgot about that. I forgot. I already forgot. This is fun. Use a preset 150. Yeah, so you preheat to 150. That was smart. Definitely a different workflow than standard. I'll give it that. But hypothetically, this will be more accurate than just a regular clicky probe. So that's cool. Or more consistent, maybe? Okay, so it probed a couple times to make sure that it was correct. And now I'm going to use a very thick sheet of paper. You can use a normal sheet of paper. I like index cards too. Just gonna hold under here and then manually lower this until we feel some resistance. So at 1, we actually feel resistance. That's surprising. Why is that surprising? I know this is a pretty thick paper, but... So this definitely feels like normal. I don't feel like the whole thing's lifting up as I'm sliding paper on. Intriguing. Okay, I'll accept that. Just to say, so Z offset is -1? How does that work? Let's save that. Save config, and then rehome the Z. Did that do anything? It says we're at 1010. Did it actually adjust anything? It saved the probe offset equals -1, but it's not showing up as that. Oh, let's see. Probe. The offset. We shows the offset of -1. But I can see my... I can see that this right here is the same. So I don't know if it's actually applied. I'm not 100% sure. Unless it's because I probed at the knob. I don't know. That's weird. Let me set it to 0.1 and see if it looks like it's a 0.1 offset. Yeah, it does. Let's see, Z equals 0. We just lifted it up ever so slightly. Yeah, okay, that looks more or less correct. Yeah, okay. All right. See if that works out then. And then one final test. Let's see if we can extrude filament. So let's go up to around 50. 51, sure. And then set this to 230. And then first I'm going to try extruding to see if it actually spins the motor. It's possible that it's not wired correctly. Let's try extruding some filament. Ooh, it does spin. It is torquey, so feels like it's wired up correctly. Oh, nope, it's not. Actually, I don't know. It's spinning correctly, but I'm able to just stop it by finger. Let's see what the current's set at. Could just be really low current. 0.3. That's very low. Let's try 0.65. See if that helps. Okay, let's keep that at 230, and then try extruding again. Yeah, that was definitely a current issue, because now I can press my finger against this, and it takes a lot more force to stop it. Like, it's harder. So that's kind of one of the first issues that I think about now is when I hear people, oh, well, I'm having extruder issues, or something's slipping, or it's not enough filament coming out. Check your currents. Check your motor currents, because that default was 0.3. That is not much. That is really not much. These things can take a lot more current. So 0.6 is pretty conservative. This is a LDO, yes, an LDO motor. So 0.6 should be fine for that. That's normally what I run my motors at. In fact, I've gone up higher on some of them, and it's worked out pretty good. So you want to see the first extrusion then, if that's the case. I haven't adjusted my E-steps though. So let me do that real quick. So this is a sail fin extruder. That's this guy right here. Let's see what the E-steps are, or rotation distance. EMG dual drive, so it should be the same as like Sherpa Mini then? Clockwork even? Same thing as Clockwork? What's the stock Clockwork rotation distance? What is it set to right now? Bondtech 5mm drive gears. BMG gear ratio. Okay, this might be correct then. If the stock config is designed for BMG gears, that's what we're using. I don't know what motor this is though, if it's an 8 or if it's a 10 tooth. Could be an 8 tooth, that's why I'm wondering. Well, easy to tell, I guess. We can just extrude something. I don't have my... Alright, we'll just use this for now. We're just going to do a very, very, very simple extrusion test. Grab some filament. Let's use whatever's closest. There we go. PLA Galaxy Black. Perfect. Throw it in there. It's the first time ever testing this system out. I have no idea if it'll work or not. A little hard to feed in. I don't know why, but let's see. See if this will extrude. Oh, and it's going backwards. Let's try retracting. Don't think it's making enough contact. Nope, too loose. All right, so pretend that the motor gear is spinning the right way. We're currently retracting, but good enough. This is at 5mm per second, so 12mm cubed flow, 230C. Hey, there we go. Hot end is doing the right stuff. Let's try 24mm cubed. Retract. Go 50mm. I think that's what we're just going to cap out as. Had a little bit of issue there. That's fine. Rejection ratio 22.6. 22.6. We are at 22.6. Yeah, okay. So assuming this is a 10 tooth stepper motor, then we should be fine. I don't know if I still have the... Oh no, it wasn't labeled. But hey, our first print. There we go. We pushed plastic. That's what everyone wants to see, right? And it's oozing plastic now. Ooh, now's a good test. Let's try rehoming the Z. I want to see what it does. Just gonna wait for it to cool down, and it's gonna probe. So awesome. Well, that was a lot of fun. A little bit of troubleshooting, and we did solve it, so yay. And that will be the final update until I get the heated bed in and get that installed. So in the meantime, I'll probably work on assembling the panels, get the Bowden tube situated, get that inlet installed up top of here. Anything kind of needing tweaking, I'll tune up and get that all assembled. We have some covers to put on. I'll make sure that the belts are tensioned. Essentially, go through the rest of the build and get it completed. A lot of little tiny things to do, but hey, this is technically a working printer now. So it homes, it does a quad gantry level, and it pushes plastic. Just gotta get that heated bed in to make our lives easier. I think I'm gonna try to print on some either Kapton tape or Pacer's tape just to test it. Just some PLA, be a good test. Remember, a lot of the Rook printers are designed to just not have a heated bed. We added heated beds because it's a lot more convenient. So this will work perfectly fine as is, but yeah, it'll be good once it's able to print ABS nice little workhorse. So you'll see another update on YouTube once we have really the build complete. I'll do a final video where I talk about any differences that might have occurred, maybe some upgrades I would recommend, etc. And then maybe make like a part 0, like watch this first type of thing, where I go over the whole build. So thank you to West3D for allowing me to build this as a beta, troubleshoot with everyone, and have a good time. So if you're interested in purchasing this kit, make sure to head over to West3D, link in the video description. If you want to purchase other things, like maybe a Dart Blaster build, West3D does carry a couple of kits now, so check those out. Otherwise than that, thank you all for tuning in. Have a great night, good morning, good evening, and goodbye.